Okay, so we're going to work through the packet, and my apologies for how difficult technology has been a little frustrating this week. And I'm sure you guys are experiencing similar things. So I'm going to get this posted to YouTube as quickly as I can so that you guys have something to work off of. And then if you want additional time with me to go over some of this or ask additional questions, please feel free to do so. So the given statements that we're going to include here for the first question is we're going to look at a given null hypothesis that the mean is equal to 4 against the alternative hypothesis that the mean is not equal to 4. Automatically, we know now that we are looking at a two-sided test. We're given a standard deviation of 0.2, and we are told um, that we are going to try to find the type 2 error if the true mean um, is equal to 4.05. And we were given a sample size of 14, and we were given an alpha of 0.01. And so we're going to use our formula that the type 2 error, you can find this in the book, is equal to the z-test statistic of z of alpha over 2, or the probability of occurrence for a z of alpha over 2, minus the difference between the means multiplied by the square root of n over sigma, and we subtract that from the z statistic of negative z alpha over 2 minus the difference between the means multiplied by the square root of n over sigma. And this is the equation that we have for finding the type 2 error. And basically, we're looking at what's the likelihood of the overlap in the curve between where we think the mean should be and where the mean actually is for a given hypothesis. And so that's what this test is really looking at. And so how often are we going to think that we should accept something when honestly we shouldn't? And so that is, in this case, 2.58 minus 4.05 minus 4 multiplied by the square root of 14 divided by 0.2. And then we have negative 2.58 minus 4.05 minus 4 times the square root of 14 over zero point 0.2. So I've just plugged in all of my information, and so that crunches down to the z statistic for 1.645 minus the test statistic for negative 3.515. Negative 3.515 is not on the chart because it's 0 approximately. So I only need to look up one of them, and it is 0.950 exactly. And so our type 2 error is 95% in this case. So question 2 tells us that we are testing a null hypothesis of a mean equal to 500 milliliters, and that's going to be versus an alternative hypothesis that the mean is less than 500 milliliters. So again, now we know immediately, just looking at the hypothesis, that we are looking at a one-sided test instead of a two-sided test. The standard deviation given is 80 milliliters, and we have 20 samples that have been taken, and those samples are going to be compared, this data is going to be compared to a critical region that was given of your sample mean being less than 450 milliliters. So we have a hypothesized mean of the mean is equal to 500 milliliters or it against it's less than 500 milliliters. The critical region for that is that the sample mean is less than 450 milliliters. So first we're looking at the type 1 error using that critical region. And so the type 1 error is also known to us as alpha. And so calculating alpha, we're calculating the probability that the sample mean is less than 450 milliliters given a population mean of 500. And so to calculate that, we're going to look at x bar minus mu over sigma divided by the square root of n. And so that is equal to 450 minus 500 divided by 80 over the square root of 20. So that has us looking at a z-test statistic for the value of negative 2.79. And so negative 2.79, that z-test statistic gives us an alpha equal to 0.0026 on the chart. So really pretty straightforward. So then the next one is asking for the type 2 error. So beta. And this is comparing for a true mean of 460 milliliters. So now what we're going to be looking at is we're going to be looking at the probability of that sample mean, accepting that sample mean when the true mean is actually 460 milliliters. So for a one-sided, our beta is 1 minus the test statistic of the 450 milliliter sample mean compared to the 460 milliliter true mean divided by 80 over the square root of n, and in this case n is 20. Let me write 20 instead since I'm already filling those in. And so that is equal to 1 minus the test statistic. I always end up tripping over that word at some point, of negative 0.56. So I look that up in my table and I get 1 minus 0.2877, which is equal to 0.7123. So our likelihood of accepting a sample when we have a true mean of 460 and that sample mean was 450 is our type 2 error there is 0.7123. So pretty high. Okay, so now we're looking at the type 2 error. We're going to change that true mean value. We're going to move it even further out. True mean of 480. And remember, we started looking at an alpha with a hypothesized mean of 500. That was the mean we thought we had. But now we're looking at this sample, the probability of this sample mean being accepted if the true mean isn't the 500 milliliters that we think it is, if it's actually a different number. And in this case, it's 480. So again, same formula, that type 2 error is equal to 1 minus the test statistic for 450 minus 480 over 80 divided by the square root of 20. And you crunch that all down and you are looking at 1 minus 0.0465, which is equal to 0.9535. So those are the first two problems. I'm going to stop the video here just to keep the video smaller, but I will post the next one immediately.